Alrighty folks, want to welcome you back to another video from Yates Computers Tips and Reviews. This will be continuing along with my collection of other videos that I've already done on network cables. Network cable is not as simple as most people would believe. There's a lot of variables and a lot of things that I've already covered in the past videos. I've mentioned before color codes, patch cables, what your drop lines are, what your riser lines, all of those, fire ratings, all of these other things that are involved in your cable. Some of the basic key things that I brought up is if you bought a pre-made cable, look at the color code. Color code is what I found to be somewhat important because I found when I've troubleshooted issues and other things, when I've looked really closely at these lines, that they are not following the color code. Like I've mentioned before, I've opened them up, there's brown and black, there's green, there's bright red, there's different colors in there that aren't CAT certified colors, that aren't certified Cat 5e, Cat 6 rated color code. So it bears to, where did that cable actually come from? What cable is between those ends? So it makes it really hard to say, okay, this is a really good cable, when you can look in there and see the colors aren't right. Here's a closer view of the four colors. Some of them, I've run across it where you have a blue and you have a light blue. You have an orange and a light orange. You have a brown and a light brown instead of a stripe brown. Because a lot of times it's really hard to deter which one's which. And it depends. It depends on how they're striped also. Let me show you on this line how, and this is Cat 6. And this is another thing I brought up. This Cat 6 I have, the standard says you're supposed to have an inner liner. This does not have an inner liner on this Cat 6. So, it's not truly up to the standard that it should be. Why it's designed this way, I'm not too sure. It might be due to a fire rating or something else, that inner liner could not meet that fire rating, so they removed it. But then, technically to me, this is not a Cat 6 certified cable. But with the extra twist and how it's done, this cable seems to perform better, or a lot of cables that I've tried, than the Cat 5e. So that's one of the interesting factors that you got to look at, is to make sure you get the proper cable. With that, you have your color code. So let me go up and show you how this is marked. See how one's white with the blue stripe around it. A lot of them, the blue stripe runs vertically down that white cable. So it can be a little hard. When you terminate these cables, it can be really hard. The ends I like are easy crimp, where the line goes through and sticks out the end. The Keystone jack, or the RJ45. The reason I like those is because of how these are color coded. Sometimes you have to really leave extra lines so you can look. Because if you end up between here and here, you have just solid white. So sometimes you got to make sure you have enough line, and when you put them in the proper order, to make sure you double check them, make sure the colors are all right. So some cabling can be actually harder to terminate than other cable, just because of how it's really marked. So that's really one of the big things about the color code. That's one of the big variables you have with the color codes. But this should meet all the standards. It should meet and pass all the standard testing. So I wanted to show this because when you're out in the field and you go to work on something and someone calls you and the line's not working, you can see the end's bad, the end needs to be changed, and you go to trim that off, you can run into issues with the colors. So that's another good reason why to really look at what's on that end. One of the other things you can do is when you have the end on there, let me grab a line. I put it away, but I need it back. When you grab a line, well, this one has the protective guard. Where did I put the other one? But if it doesn't have the boot, or it has just a boot without this piece, and you have just the line that runs in, what you do is a lot of times you can cut it further back, peel this apart, double check where all these lines run. Because again, there's two standards. But again, if you bought a pre-made cable, something like this one is, it's pre-made. There's no guarantee it's white, orange, green, or white, green, blues, green, and the browns. There's no guarantee it's that way. It could be in any kind of order that they decided they wanted to terminate this. When you test it, it'll test good, but it's not going to tell you your first pair is the orange pair, your first pair is the blue pair. It's not going to tell you that. There's other ways you can really check. If you know which ones are supposed to have the more twist, you can kind of narrow it down by measuring the distance between this end and this end. If you measure the pairs, they will read different numbers because the twists are different. So of course, the orange pair that has the most twists would read longer than the blue pair that has less twist in it, because it's actually less wire to get from this end to this end because it's not twisted as much. So that's one of the factors that cuts down on crosstalk, is those twists. So that's why you want to make sure you get an actual good rated certified cable. Cuts down on crosstalk, cuts down on a lot of things. Other important reason for the color code is you have those two standards. I don't know if anybody ever does this anymore or not, but if you hook one computer to another computer, you need a patch cable. Usually that's standard A and a standard B on each end. So your one line that transmit out is actually swapped on the other end to the side that receives. And so when that computer transmits out, it comes back on pair 1 and transitions over to the split pair greens. That's how the cross cable works. Now, like I said, it transfers over to the greens. That's not really what happens, is you put those lines into that spots on the keystone jack or on the network end on your RJ45. So that's the difference. That's how a patch cable works. And that's not patch panel cable, the flexible cable. That's a different layout than this kind of cabling. And that's for device to device. Most places now, if you have a switch, I believe a lot of the newer computers, a lot of the newer things will self-compensate now. They will know that if you hook this computer up to a new computer, direct. A lot of them, good or better network cards, will recognize, hey, I got another computer on this side, so pay attention to incoming traffic on this line. So it adapts. Now, is that best practice? No. Is that what I would recommend? No. Because now you have hardware doing a job that will actually put taxes and resources on that hardware. There's really no point for that, when all you have to do is have the right thing. Have the right cable. You can buy those cables pre-done. You can make them. But that's really not something a lot of people do. That was back in the old days. If you were gaming, you wanted to do a private network gaming between two computers, you could do that. Most LAN parties did not do that. They had a switch, they had multiple computers, so it's not really an option you use a whole lot. So that option is there. Sometimes from certain switches and certain ports and certain things, you might have to make a certain kind of cable. There are other standards in cabling. There's fiber optic type of cabling that transmits too. That's a different standard. That's completely different than CAT. So I wanted to make sure people understand that, what a CAT cable is, what it does, what the standard is. Now, there are other standards in network cable. I've run across this a little bit. T1 connections. The wiring's a little different. Of course, if you're an IT professional and you get into those type of things, you have to look those up to see what color code you actually need. They're a little different because, again, where I talked about input, output ports and those type of things, the different pins are used for different things on that port, on that jack, that you need to wire them a little differently. And usually that's just on the one end. So in here you can see the pins in here, the pins that are in here that meet the connectors on here. So how these actually connect and transmit to your computer, this has a standard between, it knows which ones it uses. 1, 2, 3, and 6 is what it uses to communicate. Now if you get into higher bandwidths, I believe like 5 gig, 10 gig, 50 gig, it actually uses all of those. So that's how it gets that extra bandwidth, because now it's not just using 2 pair, it's using all 4 pair. So these are factors that you want to look at, you want to know. But of course, if you're running a 10 gig network, hopefully you already know that. Hopefully you already have the cable, you already have everything you need. If you're looking at possibly going that route, hopefully this is information that'll help you. So for this video, I put the color code and cross cable together, because it really doesn't make a whole lot of sense to explain a cross cable without explaining color code. Because you can use either A or B standard, that's fine. I've seen other cables that have come in that I've ordered that don't follow the standard. Like I said, some of these that I've troubleshooted, they've had some weird colors and they've had some other things in them. Was there anything really bad with them? Probably not. If you used it between a computer and a switch, there would probably be no problem. Problem I had was they had 4 of those or 3 of those linked together. They were 25 foot long, so you're looking at a 75 foot long run or more with some kind of weird cable. There's a lot of no-nos there that I don't like. number one, you had a cable you don't know about. Number three was you had 3 cables. What was the number 2? I skipped it. You know why? Because that's where I've already talked about having those couplers and having the connectors and ends and all of those wires untangled, and you have all that space where you can have that crosstalk. Not to mention, you have such a critical failure point there. Because how well made is that little cheap connector? How well made is that cable you bought that you have connected to that? How well made is those pins that are in there? Because I bet you, if you bought a cheap cable, that ain't a high-end connector on there. You know, and if you bought the connectors to couple them from the same place you bought the cheaper cable, it's probably a cheaper connector. And you have multiple of these connected together. A couple scenarios I had is they had mixed flat cable and round cable coupled together. Basically, I went in with my box of cable, whoop, ran a clean new line all the way down to the other end, took out all that junk, wrapped it up, and said if you need these for something else, they're here. Use them from your switch to wherever you need to, you should be fine. But as a long 75-foot long run, no. It's a lot like TV cable. If you get into reviewing, you get into all of that, they will actually give you decimal point negative losses for every connector you have, every coupler you have, every splitter you have, everything you have on that line. It's basically the same with network cable. Except for the variable is when you get to a switch. A switch is actually a dedicated endpoint. So if you run a cable and you join it to 2 and you run it into a switch, that's your endpoint. Even though you run out of there into 2 more cables that are linked to your computer, that's a whole clean different run. It's different than hooking all 4 of those connected together. So if you research and you look at, oh, I got to run, you know, a 300-foot span of network cable, 400, 500-foot span of network cable. They're going to tell you to put switches in there. That's why you put a switch in there, because that's a dedicated endpoint. That takes your signal and goes into there and takes that signal in. From there, it rebroadcasts it out to where it needs to go. So it's not a link. It actually goes in and then it comes out somewhere else. So I wanted to vary that because that's important when it comes to this kind of stuff. And I don't know if I really mentioned that on the switches and all of that because that's kind of something a lot of people know. But because of color code, patch cables, those type of things, I wanted to cover that because if you put a switch in between 2 computers, that's something you needed to know. You don't do a patch cable. You use your standard cables, or you can run a patch cable between computer to computer so you don't have to spend money on a switch. Well, in the old days, switches used to be fairly expensive. Nowadays, I'm seeing them $50, $60, and they're great switches. They're not some low-end knockoff brand anymore that you'd get for that price. So, I know this has gone on for a lot for as simple as a color code and patch cable. But, like I said, again, this is not an easy subject. Because if you run across something like this and you don't understand how a patch cable goes and what it's used for, let's say someone has a patch cable run or they have a computer hooked up to another computer they want to add a switch. Well, they take that line out, plug it into the switch, run a line from there into there, but all of a sudden they're not communicating. It's because that's a patch crossover cable. That's a cross cable. So that's why I wanted to bring that up, because you'll run into that. Someone goes, I just did this and did that and it's not working. Again, it's as simple as having the right product. And toughest thing for you is to identify it. If you're a home user and you're looking at doing that, trying to change things because you have this one connected through Wi-Fi to a computer, and then this is connected to your other computer that draws the internet from here. You can share internet from here out because you have an older computer, and you decide to put a switch in and put this on the switch, that on the switch, and your internet coming in, and then all of a sudden it stops working. That other computer's not getting internet, it's not getting anything, not getting any communication. It could be as simple as you have the wrong cable. So I hope that helps everybody. Gone through a few scenarios there. I think I'm going to wrap this one up and hopefully start a next one. Thank you.